Welcome to Ask and Learn.
Based on Lewis structures, predict the ordering from shortest to longest of NO bond lengths in NO+, NO2-, and NO3-. To begin, nitrogen belongs in group 5A, and oxygen belongs in group 6A, so they will have 5 and 6 valence electrons, respectively. So N will have 1, 2, 3, 4, 5, and O will have 1, 2, 3, 4, 5, 6. And so the number of valence electrons in NO plus will be 1 nitrogen, 1 oxygen, and take away 1 electron. So 5 plus 6 minus 1 equals 10 electrons. And so to do this, we'll make sure that there are a total of 10 electrons in the molecular structure. As you can see the way that I drew it, there's a triple bond between the N and the O in NO+. And nitrogen initially had 5, while oxygen initially had 6. But now their valences are both 8. There's 1 lone pair here and 3 bonding pairs here. And similarly for oxygen, there's 1 lone pair here and 3 bonding pairs here. Notice that the oxygen has a triple bond, making it the positive charge for this molecule. The next molecule is NO2-. So to figure out how many valence electrons the entire molecule will have, there's 1 nitrogen, so 5 electrons, and 2 oxygens, so 2 times 6. And since the molecule will have a 1- charge, you will add 1 more valence electron to make 18 electrons. So when you draw the molecule, you need to make sure that there are 18 electrons around the molecule. So nitrogen wants 5, and oxygen wants 6. So one of these will have a double bond and the other will have a single bond. And then filling up all of the electrons, this will make 18 electrons. And if I count them out explicitly, 2, 4, 6, 8, 10, 12, 14, 16, 18. So there's 18 valence electrons in NO2. Now, for NO3- nitrate, there's a nitrogen, so 5 electrons, and 3 oxygens, so 3 times 6, and there's still a 1- charge, so we add 1 electron. So the total number of valence electrons in nitrate, NO3-, is 24. So when drawing N and 3 oxygens around it to make nitrate, since nitrogen has to bond to all of these, we need at least 1 bond to each of them. And filling up the electrons, we're definitely going to have something with a minus. But since we need to fit 24 electrons around here, the only way to do that is to have one of the bonds be a double bond, so that the nitrogen is positively charged, and that 2 of the other oxygens are negatively charged, to make an overall charge of 1-. And so if I count all of the electrons, there's 24 of them. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. And so as the sharing of electrons increases, bond length will decrease. So more triple bond character will mean the shortest bond. So NO plus will be the shortest. And since there's a single and a double bond here, but in this one there's two single bonds and a double bond, this NO bond will be longer on average than the NO bonds in NO2. So in order from shortest to longest, it's NO plus is less than NO2 minus is less than NO3 minus.